P-H-Y, 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 P-H-Y. Physics. Welcome!
Welcome to another Honors Physics Camp lecture. Today we're going to be working on some velocity practice problems. Yes, Alex, this is where the triangle method might come in handy to manipulate the velocity equation. So make sure you take good notes and let's begin. Before we get started, it's important to note the 4 variables that are involved in the velocity equation. Yes, Alex, 4. I know that we normally write the velocity equation as velocity equals change in position divided by time, but it's important to note that change in position is actually representing final position minus initial position, which is why I say 4 variables. That's right, Alex, velocity equation can be written in 2 forms depending on what variables are given. We need to keep this in mind when we're looking at velocity problems, which is why our first step is always to list out the known variables and the unknowns so that we can identify which equation is appropriate for that particular problem. Yes, Alex, you could use the triangle method for the 3-variable velocity equation, which basically allows you to visualize how to rearrange the equation when solving for a variable other than velocity. For instance, if you want to solve for a change in position variable, you simply would cover the variable and now you're left with velocity and this line that represents multiplication and time, which means that a change in position is equal to velocity times time. Now, if you want to solve for time, then you cover that up and now you're left with a change in position and this line that represents divide and velocity, which means that time is equal to a change in position divided by velocity. But keep in mind that you need to know how to algebraically manipulate the equations yourself, especially when dealing with a 4-variable equation, such as this equation for velocity. Okay, so let's try out some problems. Here we have a horse that travels down a path for 40 seconds at a velocity of 3 meters per second. How far did the horse travel? Okay, so what's our first step, Alex? That's right, Alex. We first must list out the known and unknown variables, which means that we need to identify what is given in this problem. Now, we're given time, which is 40 seconds, and velocity, which is 3 meters per second. Now, it's asking for how far, meaning we're looking for a change in position. Okay, so what do we do next? That's right, Alex. Our second step is to select an equation. And to do this, I always color code the variables such as green for known and yellow for unknown. That way, I can also color code the available equations and determine which equation would work for this particular problem based on the information provided. Now remember, in order to solve for a missing variable, the equation can only have one missing variable. And in this case, that is the 3-variable equation, which states that velocity equals a change in position divided by time. Okay, now what? That's right, Alex. Step 3 is to plug in the numbers and solve for the missing variable. In this case, we need to solve for a change in position, which means that we need to move time to the other side of the equation by multiplying t on both sides, leaving me with velocity times time, equaling a change in position. Yes, Alex, you could have gotten this equation from the triangle method. Just remember that you still need to practice how to rearrange equations, and the triangle method could simply help you verify that you rearranged it correctly. Okay, so this means that we need to multiply 40 times 3, giving us 120 meters. Let's take a look at this example. A swimmer swims for 48 seconds from the 10-meter mark to the 100-meter mark. So what's our first step, Alex? That's right, Alex. Let's list out the known and unknown variables, such as the time given, which was 48 seconds, the initial position, which was 10 meters, and the final position, which was 100 meters. Then we are asked to find the velocity. What's next? That's right, Alex. Our second step would be to color code the variables to help us select an equation, leading us to use this equation since we have all the variables except one, which is the unknown. Now, let's move on to step 3. You got it, Alex. Step 3 is to plug in the numbers and solve for the missing variable. In this case, we need to solve for velocity, which means that we simply need to plug in the values for the final position minus the initial position and then divide it by the time, resulting in a velocity of 1.87 meters per second for this swimmer. Next example, a car travels a velocity of 16 meters per second from 20 meters north of your house for 1,000 seconds. What is your final position from your house? Okay, so let's start with our first step. Good job, Alex. Let's list out the known and unknown variables in which we know that the car's velocity is 16 meters per second and the initial position is 20 meters north. In other words, positive 20 meters. And the time is 1,000 seconds. Now the problem asks us to determine the final position from your house. Now what do we do next, Alex? That's right. Our second step is to color code our variables so that we can select our equation. This is going to lead us to this equation, since we have all of these variables except one, which is the unknown. Now, let's move on to the third step. You got it, Alex. Step 3 is to plug in the numbers and solve for the missing variable. Now, in this case, we need to solve for final position, so we need to move time to the other side by multiplying it on both sides, resulting in velocity times time equals final position minus initial position. Now we need to add initial position on both sides so that we can leave final position alone, resulting in velocity times time plus initial position, which equals final position. And then we just need to plug in the values, resulting in final position of 16,020 meters from your house. A dog chases a cat down the street at a velocity of 0.5 meters per second for 10 seconds and ends up 30 meters north of your house. What was his initial position? Let's start with our first step, which is to make our list of the variables. Good job, Alex. We know that the dog's velocity was 0.5 meters per second and that he was chasing the cat for a total of 10 seconds, resulting in the dog's final position to be positive 30 meters from your house. The problem asks to determine the dog's initial position from your house. So what do you think we should do next? You got it, Alex. The second step consists of color coding our variables and selecting the right equation to use. Okay, what's next? Right again, Alex. Step 3 is to plug in the numbers and solve for the missing variable. In this case, we need to solve for initial position, so we need to move time to the other side by multiplying it on both sides, resulting in velocity times time equals final position minus initial position. Now we need to add initial position to both sides, resulting in velocity times time plus initial position equals final position. Now remember, we want initial position by itself, so we need to move velocity times time to the other side. Notice how these two variables are together, and they are getting added to initial position, so that we can leave initial position alone, resulting in initial position equals final position minus velocity times time. And now we can plug in the values, resulting in an initial position of 25 meters north from your house. This concludes our video lecture. Make sure that you took good notes, and that's it. Have a great one.